Have you ever wondered how something as invisible and vast as gravity actually works? It is not just a mysterious force pulling things down, but a fundamental property of the universe that shapes everything from apples falling from trees to the orbits of galaxies. Yes, the trampoline analogy can be a really helpful visual aid for simplifying spacetime curvature, but it is important to remember it is an analogy, not a perfect model. It successfully illustrates how mass influences the fabric of space around it, giving us an intuitive starting point for understanding Einstein's general relativity. The core idea behind the trampoline analogy comes from Albert Einstein's theory of general relativity, which tells us that gravity is not a force in the traditional sense, but rather a manifestation of the curvature of spacetime itself. Imagine a bowling ball placed on a stretched rubber sheet, which represents space. The ball creates a dip or a curve in the sheet. If you then roll a smaller marble nearby, it does not move in a straight line across the sheet, but instead curves inward towards the bowling ball, not because the bowling ball is pulling it directly, but because the sheet itself is curved. This visual effectively conveys how massive objects like planets and stars create dimples in spacetime, and other objects simply follow the curves in that geometry, giving us the effect we perceive as gravity. To use this analogy effectively, focus on its strengths, visualizing how mass distorts its surroundings and how paths of objects are influenced by this distortion. It helps build an initial mental picture. However, always acknowledge its limitations. The trampoline only shows two spatial dimensions curving, while actual spacetime involves 3 spatial dimensions and 1 time dimension, all curving together. Additionally, the marbles on the trampoline are pulled towards the bowling ball by Earth's gravity, which is the very force the analogy is trying to explain, creating a slight conceptual loop. The analogy also fails to show how time itself is warped by mass. In reality, objects in curved spacetime follow paths called geodesics, which are the closest things to straight lines in a curved geometry. Think of it like flying a plane over the Earth. The shortest path between two cities on a globe is not a straight line on a flat map, but a great circle route that appears curved. Similarly, planets orbiting a star are not being directly pulled. They are following the straightest possible paths through the star's curved spacetime. So, while the trampoline analogy is a fantastic starting point for visualizing a complex concept, remember its purpose is to introduce an idea, not fully representing it. By understanding both its power and its pitfalls, you can use it as a helpful mental tool to begin to appreciate the truly mind-bending nature of gravity as the curvature of spacetime, an invisible cosmic architecture shaping our universe.